Welcome to Brain Vision.
That we will need to give a bullet at a temperature of 25 degrees Celsius, so that at that instance, when it comes to rest, we'll be able to know how much heat that will be generated to heat this lead bullet. Okay, all right. Now, in this situation, what we need to analyze is first and foremost analyze the energies involved in this scenario. All right. We know when we come to dealing with guns or bullets, we can talk of heat. Okay, we can talk of heat attached. Now, the energy that is associated with any bullet that is fired from a rifle will basically be the kinetic energy. Okay, so let's say initially the bullet was at rest inside a rifle. The moment it's fired, it will be converted into what? Kinetic energy. Now, as it's converted to kinetic energies, let us not forget that there is some sort of thermal energy also involved inside of this picture. All right, so we are saying that the total kinetic energy will be equal to the thermal energy in that process. So how do we go about this? Let's deal with this. So the kinetic energy half mv squared minus half mu squared, where v is the final speed. Okay, v is the final speed, and then u is the initial speed or velocity. The initial speed. All right. Now we are saying that this kinetic energy is equal to the thermal energy. All right. So let me rewrite this equation as half v squared. Half v squared minus half mu squared is equal to the thermal energy. We have mc delta T plus mLF. Now remember, we are also considering the heat energy required to melt the lead bullet. All right. Now, when we look at this equation, we can see that we have mass throughout the equation. So let's factor out the mass. So we have the mass out of the bracket. We have v squared minus half u squared is equal to the mass out of the bracket. We have c delta T plus LF. All right, so this mass cancels this mass. So what it means is that we can't work with the mass as of now. So we just go on straight away and only work with the speeds of the bullet and then the specific heat capacity of the lead bullet, the temperature changes, and then the latent heat of fusion, which is for the melting process. All right, for the melting process. Okay. Now, since the bullet will be coming to rest, we will say that the final velocity of the bullet, that is v, is equal to 0. Okay, so if v is equal to 0, then what it means is that all of this will be what? 0. All of this will be equal to 0. So what it means, our equation will be left with negative half u squared is equal to c delta T plus LF. Okay, all right. Okay, so let's write some few informations down. Now, we need to know the temperature at which a lead bullet will melt. The temperature in which a lead bullet will melt, and that is about 327 degrees Celsius. Also 327.5, let's say 0.5 degrees Celsius. All right. Now, what is the latent heat of fusion of this lead? It's also giving us 24.5 times 10 to the power 3 joules per kilogram per Kelvin. Joules per kilogram. Joules per kilogram. All right. So let's go on to add up all the other informations concerning this equation. All right. So we have, since we are dealing with speed, let's ignore the negative sign in here. We are assuming that the speed is scalar, so we don't need to factor so much or think so much about the negative sign. Think so much about the negative sign. So we'll say that half u squared is equal to, the specific heat capacity, which is this C for the lead bullet, is 130 joules per kilogram per Kelvin, okay, multiplied by the temperature change. So we are looking at a temperature change between the melting point, which is 327.5 minus 25 degrees Celsius, plus 24 plus 24.5 times 10 to the power 3. Like that. Good. All right. So now that we have this, let's move on to look at it. So making u the subject, u squared the subject, we have u squared is equal to 2 into bracket. We have 3,9. If we simplify that, we have 39299 plus 2450 is basically this value that I've just changed it in a different form. Just the same thing. Okay. All right. Then we close it. So when we do that, we have our u squared to be equal to 1,27598. Okay, 98. All right. So we say u is equal to the root of 1,27598. Okay, the square root of 1,27598, and that should give us about 357.2 meters per second. Okay, so this is the initial speed.